Bismillahirrahmanirrahim. I have already taught to you in detail in different lectures about the ideal gas and the real gas. But here we will see the difference between the ideal gas and the real gas. So some important points are given over here to have the difference between the ideal and the real gas. The first one difference is the ideal gas is having no definite volume, and this is because the particles of the gas themselves, the volume of the particles of the gas themselves is negligible as compared to the total volume, and this is according to the kinetic molecular theory. That's why this is having no definite volume, and but the real gas is having a definite volume. That's why these are the real gases. So the other one difference is the ideal gas is having the intermolecular forces of attraction, and sorry, the ideal gas is not having the intermolecular forces of attraction, but the real gas is having the intermolecular forces of attraction. So this is also according to the kinetic molecular theory. The molecules or the atoms of the gas are moving randomly, that and they do not have any intermolecular forces of attraction, but opposite to the ideal gas, real gas is having some sort of the intermolecular forces of the attraction. So the third difference is the ideal gas does not really exist in the environment, and it is a hypothetical gas, and this is because this is the ideal, and it is very rare that the gas does not has the volume, or there is no intermolecular forces of attraction. So this is actually, they do not really exist in the environment. But opposite to the ideal gas, real gas is having a definite volume and the intermolecular forces. That's why it really exists in the environment. And all the, like the oxygen, nitrogen, all these gases are the real gases. The fourth one difference is ideal gas is having high pressure, and high pressure is because there is no intermolecular forces of attraction. So the collision of the particles on the walls of the container is high. That's why it is having the high pressure. But the real gas is having less pressure as compared to the ideal gas. So this is the difference between the ideal and the real gas. The the fifth one is difference is the ideal gas is behaving independent, or the molecules of the ideal gas are independent. That means they do not interact with another molecules because of the no intermolecular forces of attraction. But the real gas, the molecules interact with the others because of some intermolecular forces of the attraction. And the last point is because this is ideal gas, it must obey the ideal gas equation, which is the PV is equal to nRT, and the real gas is following the van der Waals equation because there is the deviation in the pressure and the volume, and this is the correction in the pressure and the correction in the volumes, and this we have already discussed in the van der Waals equation. So if it is a real gas, this has to obeys the van der Waals equation. So these are the some differences between the ideal gas and the real gas. Now I'm going to show you one of the numerical, which is going to help you to understand actually what is the difference between the ideal and the non-ideal gas. So let's have another document. This is the questions. Calculate the pressure exerted by 0.3 mole of helium in a 0.2 liter container at minus 25 degrees centigrade using the both ideal gas law and the van der Waals gas law. So if we will check the ideal behavior of the helium, and we will check also the real behavior of the helium, and later on we will discuss the what would be the difference between the non-ideal mean real gas and the ideal gas. So these are the constant A and B. These are the constant for the pressure and the volume in case of the you put the data in the van der Waals equation. So all factors of the data is given over here. Let's first solve part A. Part A is by using the ideal gas law, and ideal gas law is the uh, PV is equal to nRT. P is the pressure, V is the volume, N is the number of moles of the gas, R is the gas constant having this value, T is the absolute temperature. And the first, you have to find out the absolute temperature, because the temperature in Celsius is given, which is the minus 25. You have to add 273, and this will give you the value 248 Kelvin. Now you just use this equation, PV is equal to nRT, and you have to find out the pressure, because all rest parameters are given. So you have to calculate the pressure, and by using the pressure, we will discuss the difference between the ideal and the non-ideal gas. So pressure will be equal to nRT over V, and when you put all these values in the formula, this will give you the value 30.55 atmosphere, and this is the pressure of the ideal gas, because this is the ideal gas equation. Now for the real gas, we are going to use the van der Waals equation, and van der Waals equation is this, and this is just taken as the square is the common, actually is the A n square over V square. So this is the same as we have discussed in the previous lecture. So again, where P is the pressure, V is the volume, N is the number of moles of the gas, A is the attraction between the individual particles, B is the average volume of the individual gas particles, and having these constant values. R is the gas constant having this value, T is the absolute temperature, and now you can solve for the pressure. Similarly, what we have done for the ideal gas equation. So this is the van der Waals equation. When you get the pressure over here, you just rearrange this equation, and this equation will become like this. And now you can just put all these values in this formula, or you can use in two parts to make it easy for the calculation. So this, let's suppose this is the part A, this is the x minus y. So pressure will be equal to x minus y. So first I'm going to calculate this one, then I will be calculating this value, and later on we will subtract this minus this to have some easier way to calculate the pressure. So here x is equal to this, and again as x equal to nRT, y is equal to this xRT, x is nRT over v minus nb. When you put all these value, finally you will get the answer 32.152 atmosphere. You can now you can solve y is your second part, this is your y, and this is the a n over v square, and when you put all these value over here, finally you will get the answer 0.077 atmosphere. Now you can recombine the two to find out the pressure. X minus v, x is this, y is this, and when you solve this one, the pressure is the 32.075. And remember, this is the pressure for the non-ideal, or you can say this is for the real gas. So your third part is now find out the difference between the ideal and the non-ideal condition. So for the ideal, non-ideal minus ideal, you have already calculated the pressure. So you are just subtracting the pressure from the non-ideal of the ideal equation. So when you find out this one, the difference is 1.602. So here is the statement, that means the pressure of the ideal gas is 30.55. So pressure, it is the, and pressure for the and the pressure for the non-ideal by using the van der Waals equation is 32.152 atmosphere. So the difference between is 1.602. That means the pressure of the non-ideal gas is higher by the factor 1.602, and this is the difference what we have discussed in the previous slide. The non-ideal gas having the pressure which is exerted by the 1.602 as compared to the ideal gas equation.